Hello everyone, I'm Guilherme Souza from the University of Aveiro, and I'm here today to present you the model of Introduction to Cork Science, cork cultivation, harvesting and processing. The cork oak, or Quercus suberelle, its scientific name, is an evergreen oak with a thick, wrinkled bark and a persistent cork covering. Two cork oak agroforestry systems exist: cork oak woodlands, which consist of a relatively sparse forest, and cork oak forests, a denser stand in a mountainous region. The cork oak grows in southern Europe, North Africa, and the western Mediterranean. Besides making cork, the land is usually used for hunting and letting cattle graze. This semi-tolerant species does well in mild climates like the Mediterranean, which has mild winters and hot, dry summers, and in soils with low fertility. Cork oak forests are important for the environment because they stop desertification and soil erosion and help keep a variety of species alive. The cork woodlands are one of the 36 most important ecosystems in the world for preserving biodiversity. Others include Amazonia, Borneo, and the African savanna. The cork oak has a lot of ecological flexibility. It can change its phenology and physiological activity in response to changes in the environment, such as high temperatures and even drought. Regarding how much it rains at different times of the year, it is used to getting more rain from October to March and a very little or no rain at all in the summer. The best average annual temperature is between 13 to 16 degrees Celsius. Winter has an average low temperature of 4 to 5 degrees Celsius. Still, it's important that cork oaks respond well to rising temperatures and that the best temperature for cork oak seedlings is 33 to 34 degrees Celsius. Most of the time, the minimum and maximum temperatures are around -5 and 40 degrees Celsius, respectively. The species is also very tolerant of soils, with the exception of those that are calcareous or made of limestone. Cork oaks increase the amount of organic matter in the soil by looking for nutrients in the subsoil and returning them to the soil when their leaves and branches fall off. This makes the soils more productive. Cork oak forests and woods cover the western part of the Mediterranean basin, over 2 million hectares. In particular, in the southern part of the Iberian Peninsula and in northern Africa. France and Italy also have cork oak trees. Portugal and Spain have the most cork oak forests and make most of the cork products in the world. Portugal has the most montado and makes the most cork products. It also exports the most cork products because it makes the most. About 374,000 tons of cork products are made each year, and most of them comes from Portugal and Spain, which are responsible for 74% of the world's total. There are other cork trees beside Quercus suberelle, such as Quercus variabilis and Quercus ceres. This one grows well in Asian climates and is often called Chinese cork oak. Cork from Quercus variabilis has a similar microscopic structure to cork from Quercus suber, but the cells are much more wavy and collapsed. About 1.2 million hectares of forest are made of Quercus variabilis, which is used to make about 50 to 100 kilotons of cork. Even so, there is a big difference in quality. Cork from the tree called Quercus suberelle is a much better raw material. The cork oak is in the order Fagaceae and the family Fagaceae. This group is thought to have more than 40 different types. They have different shapes and sizes of leaves, flowers, and fruits, as well as different flowering times. The shape of the tree itself can also be different. Introgressive hybridization, which is the transfer of genetic material from one species into the gene pool of another, is a big reason why there are so many different shapes and behaviors. Cork oaks are trees with short trunks and thick branches that can grow up to 16 meters tall. Still, trees that grow in less dense stands can have big stem diameters and crown sizes. In dense stands, where there are a lot of trees close together, the trees usually have narrower crowns and taller stems because the other trees affect their size. The root system of this species is two-sided, with a strong long taproot and thick lateral branches. In open-grown trees, the lateral branches may spread out horizontally and have many shallow roots. The main root can grow down several meters into the ground. The buds are round, dark purple, and only about 2 millimeters long. The leaves are dark green and have a dense covering of white hairs on the underside. The epidermal plane has a dense network of stomata with guard cells that reach out from it. The shape of the leaf can be round or oval, and the edge can be crinkled or waved. Buds start to grow in February or March, which is when the physiological activity starts. It grows longer and makes new leaves from early spring until June. Because the leaves fall at different times of the year, the tree's crown in the spring is still dominated by the fading color of last year's leaves, while other species have new leaves. When the cork oak is between 15 to 20 years old, it starts to fruit and flower. Pollination happens in the spring. It can happen with pollen from the same tree or from trees close by. The cork oak's fruits and acorns come in different shapes and sizes, ranging from less than 2 centimeters to more than 5 centimeters in length. Acorns can be ready to eat once a year or every 2 years. In the first case, the acorns grow during late summer and fall, and they are fully grown by November. As for the ones that live for 2 years, they have a period when they grow slowly and then a time when they grow quickly in the spring of their second year. A tree usually has 2 or 3 years every 10 years when it makes a lot of acorns. The vast majority of cork oaks grow from acorns that sprout on their own. Artificially regrowing cork oak stands is a fairly new idea that has come a long way since the 90s. In Portugal and Spain, several thousand hectares of cork oaks have been planted or grown from seeds directly in the ground over the last 15 years. But the death rate is often high in the first few years. Most of the time, it's because the soil isn't good enough or hasn't been prepared to grow a strong root system in time for the summer. Or the young plants are sensitive to water stress, and small rats and cattle love eating acorns and young plants. Site preparation includes getting rid of weeds, which is often done with a disc harrow, and improving the soil so that roots can grow better. Preparation methods may include ripping or subsoiling to a depth of between 60 to 80 centimeters, plowing and mounding along contours, and then deep plowing and or disc harrowing. It could cover the whole area or just stay at the planting line. Most of the time, 40 to 100 grams of a fertilizer made of nitrogen, phosphorus, and potassium are put on each plant. Less trees are planted per hectare than with other types of trees that make wood. To find a good balance between density and cost of installation, spacings of about 4 square meters are suggested. Still, both wider and denser spacings are used. Due to the high rate of death in the first few years, the plant is considered to be well established when it is 8 to 10 years old. People think that putting individual tree shelters around young seedlings will keep animals from eating them and help them grow taller at first. However, this method has led to more young plants dying and stems that are thinner and less developed. When there isn't enough rain in the spring and summer, irrigation should be done twice or three times during times of high stress. During the first few years after planting, you should also pull weeds. This is the time between when the tree is planted and when the first cork is taken from it, which usually happens between 25 and 40 years of age. In most places, like Portugal and southern Spain, 25 years is enough. Young trees have a lot of branches and often don't have a main stem, so trimming is very important if you want a clear stem that is at least 2 to 3 meters tall. Because cork oaks are very vulnerable to competition in the first few years, they should be weeded no later than 4 to 5 years old and then every 3 to 4 years until they are at least 10 to 15 years old. From the cork oak forest to the customer, the whole cork chain depends on consistent and long-lasting cork production and by extension on how well cork oak forests are managed. The Worldwide Fund for Nature says that nearly 100,000 people in southern Europe and North Africa depend directly or indirectly on these woodlands. These forests are a great example of how to protect the environment while still making progress. For example, no trees are cut down during the cork stripping process, which is a first in terms of sustainability. Cork oak forests are different from other types of forest because the product is not wood, which kills the tree, but the bark, which can be taken from the tree more than once. Cork growth is an important factor for forest owners and a key factor in forest management. It determines the properties of the raw material for industrial processing, since cork is used to make wine stoppers, which require a minimum thickness from planks. Cork production yields depend on cork and tree growth, as well as managing factors like how much cork is taken from the tree, how often it is stripped, and the area that is stripped. Many people worry about the future of cork oak forests and the cork chain because they are so important for protecting the environment from soil erosion and desertification and from the social and economic well-being of people and places in trouble. Cork also has a big impact on society and culture that goes far beyond its growth area. Most of the worries about the future of cork oak forest come from the Montado and Dehesa systems, which don't have enough time to grow back. In these sparse environments, natural regeneration doesn't happen very often, and most of the trees are already old and dying. Even though there are usually a lot of baby plants near old cork oak trees in the spring, most of them will die in the following year. This is because the acorns that fell all over the area sprouted. Dense cork oak forests, on the other hand, show that the opposite is true. These are the best places for natural regeneration to happen. Even though growth is slow because there are so many plants, there are a lot of young plants in these stands. In spite of this, the forest area is very small compared to the size of the Montado and the Hisa systems. Cork oak stands need to be artificially regenerated through seedling or planting seedlings grown in nurseries to make sure they will be around for a long time. After preparing the soil, these reforestation projects plant about 600 trees per hectare in a very close space. The fact that cork oak stands serve many purposes, especially in the food chain, is another thing that could stop them from growing back on their own. For example, young plants that have made it through the harsh summer weather are at risk when cattle are around. When this happens, farming should not be allowed in the area until the young trees are at least 10 years old. Europe and the rest of the world both want to take care of forests in a way that is good for the environment. International resolutions have recognized and worked to improve the forest's important role on the planet. These resolutions have focused on the forest's many functions that contribute to society's sustainable development, especially in rural areas such as making renewable goods and protecting the environment. The goal of sustainable forest management is made easier to reach by a set of criteria and the indicators that go with them. Criteria cover all parts of forest management and are used to judge how well the management is going. The indicators are quantitative, qualitative, or descriptive measures of or parameters that, when measured or controlled regularly, show how a criterion has changed. Cork oaks don't get many serious diseases. In cork oak literature, more than 300 kinds of fungi and homicides have been named. At least 100 of these are dangerous. Luckily, only a few of them are primary infections that can hurt healthy trees. Recently, several species of opportunistic fungi have gotten more attention because they can live in oak tissues as endophytes for a long time without showing any signs of disease. The pathogens that do the most damage to cork oaks do best when droughts happen more often and are stronger when temperature rises. Some of these pathogens cause cork oaks to decline and eventually die when they are combined with climate-caused stress on their bodies. All over the world, forests are dying because of global warming. In the Mediterranean, this is shown by rising average temperatures and a general decrease in annual rainfall, which is becoming more unevenly spread across the seasons and often causing them to last longer. In order to increase cork production in the face of climate change, forest management practices could be changed. For example, cork extraction schedules could be optimized, the barking surface could be lowered, and the number of trees could be increased. How well a pathogen can live and spread depends on a lot of different things. These include temperature, rainfall, relative humidity, light, leaf moisture, solar radiation, air turbulence, and other things. In the southern part of the Iberian Peninsula, long droughts and wet seasons, bad site characteristics, and a disease-friendly environment make it easy for pathogens to spread. Also, a lot of physical stress makes trees less healthy, which makes them more vulnerable to parasites. When pathogenic endophytes were combined with constant dryness, the number of infections went up. This has been linked to the loss of cork oaks. Cork extraction, also called cork stripping, is an old manual process that involves cutting large rectangular planks that are then pulled from the tree. To avoid damaging the bark of the tree, it takes careful and experienced hands. Using the softness of the phylogen and the newly formed cork cell layers, the bark is peeled off the tree without hurting the inner bark or cambium. The cork oak can be stripped 15 to 18 times over the course of its life, about every 9 years. The first time, when the cork is still virgin, is when the tree is 25 years old. At the age of 34, they get the secondary cork, and at the age of 43, they get a reproduction cork, which has the best qualities for making the best stoppers. There are 5 steps in the process of stripping the cork oak. First, open. Cut the cork plank vertically along its most visible groove with the axe to separate it from the base. Second, separate. To separate the plank, twist the edge of the axe between the plank and the bast. Third, scribe. The size of the cork plank taken from the tree is determined by a horizontal cut or scribing. Fourth, extract. The plank is taken off the tree carefully so it doesn't break. The bigger the plank, the more valuable it is for the business. Fifth, waste removal. Some pieces of cork are left at the base of the tree. These pieces are hammered many times to kill any parasites that might show up. When the phylogen mother cells and newly made phloem cells are swollen and the cell walls are thin and weak, this is when the bark is pulled off. In this state, a small force in a radial direction is enough to pull the bark apart at the level of the phylogenic active zone. The timing of this operation is very important if you don't want to hurt the phloem and the cambium below. So cork extraction can only happen when the phylogens are most active, which is usually between mid-May and early August. One common way to do this is to see how easy it is to get cork from a few cork oaks. Normal methods can be used to remove the cork if it isn't easy to get off. If too much force is used, the cambium may break, causing damage that can be fixed. The cork has to be peeled by hand. Usually, there are 2 people on the work crew, and they both strip the same tree at the same time. To separate the cork planks, use a tool called a stripping axe. It has a curved blade for cutting and a long wooden arm with a chiseled end. To separate the cork layer, you put the axe's arm into the cut and pull it out. The next step is to get the cork plank. At the bottom of the stem, the strip of cork that touches the soil is taken off. This leaves a clean, stripped surface. When it comes to big trees with short trunks and many thick branches that spread out, cork stripping is done by several groups of people who have to stand on the branches to move up the tree. Cork stripping is done by a large group of people, most of whom are experts in cork harvesting and number about 100. Cork strippers are part of these groups, but there is also a manager and people who gather the planks and bring them to a central location, as well as people who stack them. Some attempts have been made to automate the process of removing cork. Even though more complicated methods like using a high-pressure water jet or a laser beam have been tried, they can't be used because they are too hard to use or too expensive. After the cork bark is taken off, the cork oak stem looks smooth and golden brown. In the weeks that follow, it gets darker. Cork stripping is measured by how much bark is taken off compared to the size of the tree. The debarking coefficient is the ratio of the debarking height to the cork oak circumference at chest height. The debarking coefficient is limited by laws or procedures for good practices. In Portugal, the law says what the maximum debarking coefficient can be. It depends on how old the tree is. The first cork stripping has a debarking coefficient of 2, the second 2.5, and the third 3. At chest height, the tree has to be 70 centimeters around or 22 centimeters in diameter before the cork can be taken off. This is also the limit for how much can be taken out of a branch. Depending on the radial growth, the age of production will change. Most people agree, though, that the required diameter is reached after 20 to 25 years of normal growth or 30 to 40 years in less than ideal conditions. The amount of cork that is stripped depends on how often it is extracted. The number of years between two extractions is called the production cycle. A lot of research has been done on how cork grows during the cycle, and it seems that the length of the cycle is based on the need to get the cork plank to a certain thickness so that it can be used in industry. In both Portugal and Spain, the minimum time between extractions is set by law at 9 years. By counting the rings on a cork's cross section, you can figure out how old it is. The years it took to get the cork can be counted as half years. To help with forest management, the last digit of the year the cork was taken off is painted in white on the tree stem after the cork has been taken off. For example, if the cork was taken off in 2005, the number 5 is painted. If the cut isn't strong and quick, the cork will absorb most of the energy. However, the cut shouldn't be so strong that it goes through the phloem or cambium. Wounds, like the ones that happen when you take out a cork, are entry points for diseases and biological attacks. In fractionated stripping, the tree responds by making calluses on the stem that sometimes stick out quite a bit. These calluses mark the line between extractions. Cork production goes down in the reaction zones, and the next strippings are harder to do and have a higher chance of hurting someone. The tree's health is directly affected by the removal of cork. The area where the cork was removed loses more water through stem transpiration. This throws off the plant's nutritional processes, which don't go back to normal for 30 days. During this time, traumatic phallogen and several layers of cork cells form to protect the active phloem from losing more water. But it seems that when a tree starts making cork, the wood changes. The cells are smaller and have thicker walls. There are more fibers, and the wood elements are spread out in a different way than they are when the tree is making early wood. The people who remove the cork planks leave them on the ground. Then a tractor will pick them up and put them in the yard. Putting together piles is a careful process that starts with choosing the site. The cork planks are shaped like the stem. These are put on top of each other with the cork side facing up, and the planks are placed in a way that makes a straight and solid outer wall for the pile. Planks of different sizes and shapes are put in the middle of the pile. As soon as the planks arrive from the stand, the pile is built. Since no segmentation has been done yet, it has cork planks of different thicknesses and qualities. Even though pieces from the center of the pile are sometimes taken before making an offer, the planks that can be seen play a big part. The price is based on weight, and the standard unit of weight is 15 kilograms, 1 arroba. Recently, fuel storage and building piles were taken away, and now cork planks go straight to the industrial yard after being stripped. But for the cork to fully mature and stabilize, it needs to be left outside after being stripped. The International Code for Cork Stopper Practices has strict rules for this step, such as stacking planks for at least 6 months under non-contaminating material. When cork is being stripped, it has a lot of water in it. This makes sense because the phallogen is active and the cells in this area are thick. After being stripped, cork planks have about 25% water left in them. The middle of the cork plank is wet while the edges are dry. When it's taken off the tree, cork has less water than wood does when it's harvested. The reason is that cork doesn't absorb much water and the outer layers of the periderms takes a long time to dry out in the current cork cycle. Cork planks lose water quickly at room temperature. After about 9 days of being stacked in the field, cork planks should have less than 40% water content and can be sold as dry cork. Cork that has reached equilibrium has a moisture level between 6 and 10%. When people talk about selling a cork pile, they usually agree on a price when the pile is weighted. Cork that is carried right after it's stripped or soon after has a 20% water discount. The actual amount of water can be estimated, and the amount of water in relation to the weight of the cork can be worked out. The weight discount due to water can be worked out for a completely dry cork or an air dry cork with 10% moisture. Traditionally, industrial mills have a large open area on their grounds where they store cork raw materials. The cork plank storage area, also called the stabilization area, has a slight slope and is cemented to keep rainwater from collecting close to the ground. This safety measure is meant to stop microbes or contamination from growing in the cork planks, which could cause or bring out moldy flavors. Cork plank piles in the yards can be set up in a regular way or in a more random way if they are set up right after the truck is unloaded. At the mill, the place of origin of raw materials is kept track of, and storage piles are separated by places of origin as a first step toward finding out where the cork came from in the industrial process. In the past, cork planks were stored for up to 2 years. then for only 1 year. This was said to be necessary for their chemical and structural stability. Officially, the best way to store something now is for 6 months, but raw materials are often processed with shorter storage periods because cork production is seasonal and raw materials are very expensive. In order to get the cork ready for industrial processing, the planks are put on pallets and boiled in water at a storage yard. During this process, waste raw cork planks and cork planks with moldy spots and yellow stains are separated and labeled as being of very low quality. Virgin cork is made in the oak's first periderm and can be seen on young trees before the first cork is taken, or on mature cork oaks with branches that have not been stripped. So, the first time cork is taken from a tree at age 25, it is called virgin cork. This cork can be used to make cork stoppers because its structure is uneven and too hard. Secondary cork. After the first cork is taken off, the new damaged periderm grows until the next cork is taken off. This second stripping happens 9 years after the first one. It makes the cork more uniform and less stiff. On the other hand, secondary cork often has deep cracks. Reproduction cork is in the next periderm, which grows when the tree is about 43 years old, and any others that may grow after that. This is the raw material that will be used to make stoppers by the industry. The last type of raw cork is cork wood or winter cork. You can also get virgin cork from branches that have been pruned or young trees that have been cut down during thinning. Since cork hooks are cut back in the winter, the cork layer sticks strongly to the inner bark. With a small axe or debarking equipment, the cork is taken off by hand. On the table, you can see where different types of raw cork come from, what their main use is, and what makes them unique. The industry makes a wide range of products that use cork in different ways and use different kinds of technology. Still, making natural cork stoppers is the main thing that determines the economic viability of the whole sector. The thickness of the plank is the most important factor in deciding if raw material can be used for processing. The most important thing is how many cork planks have the right thickness, at least 27 millimeters, for making stoppers. This is a variable in forest management that foresters can use to maximize production value while taking into account industrial needs. Also, the quality of cork planks is thought about in terms of how uniform the cork tissue is. Too much porosity, which can be caused by lenticular channels and other breaks like cracks or insect galleries, lowers the production output and quality of stoppers, which could lead to quality rejections. The size of the tree and how the cork oak is stripped affects the size of the raw cork planks. They look like rectangles and are about 1 to 2 meters high and 40 to 80 centimeters wide. Pieces with a surface area of less than 400 square centimeters don't qualify as planks, so they are stacked separately. Porosity, caused by lenticular channels, is a natural and important part of a tree's physiology that lets the tree's living cells communicate to the outside world. This can be thought of as a flaw, but if there is too much of it, it can ruin the plank so much that it can no longer be used as a stopper. Cork can also have biological or external characteristics that are related to the structural flaws and, depending on their type and amount, change the quality of the raw material in some way. This can be grouped into insect galleries. Insects can attack the cork oak when they make nests in the cork tissue. The nail defect is made up of thick-walled cells that have turned into lignin in the cork tissue. Because of this, they are tougher, more dense, and less flexible. The plank back may have a deep sulcus. They go up and down and into the cork tissue. The groove lines show that the growth tangential stress caused the tissues to break down. Planks can get stains like yellow and marble on them when microbes attack them. Because of this, stained corks aren't used to make wine stoppers. Instead, marble stained cork might be more useful as a decoration because of the random way the stain spreads and the dark lines that follow the shape of the cork. Wet cork. This is a defect in the cork that causes the humidity to be very high and use cause is unknown. Most of the time, this problem happens in the most recent annual layers. The thickness of the planks is the main factor that determines the final use of natural cork, which affects how it is processed and sold in industry. The industrial method is to group cork planks by how thick they are. The classes were made up with the idea that they could be used for more processing. The best thickness range for making cork stoppers is between 27 and 32 millimeters, so cork manufacturers try to make cork planks in this range. From front to back, the thickness of the plank is measured. Cork planks for sale are put into different classes based on how good they are. The quality of the cork plank is judged by looking at its transverse and radial parts as well as its belly surface. The first quality criterion has to do with how porous the lenticular channels are. Second, the fact that there are flaws and how they might affect processing. Cork planks are put into six classes, first to sixth, based on how good they are, plus a seventh class for the ones that can be used. The sixth quality and refuse way of putting cork boards into groups is no longer used. Instead, more aggregated quality classes are used. For example, the first to third group represents high quality corks, the fourth and fifth group represents medium quality corks, and the sixth group represents low quality corks. Another option, which is probably the most common, is to divide the quality of planks into only two groups: a first to fifth group of cork planks that can be used to make cork stoppers, and a sixth group of lower quality planks that can also be used to make stoppers. Since the plank value is based on both the thickness and the quality of the porosity, it has been suggested that the combined variable be used to show the cork value based on the relative commercial value of different thickness ranges in quality classes. This can be used to figure out how much a certain cork stand is worth to make, taking into account the thickness and the quality of the planks. This is called the integrated value index of cork. The prices are based on the most valuable class of cork quality, as shown in the table below, just as an example. Clearly, the numbers may need to be updated to reflect changes in the cork market or special trading and processing conditions. After the raw cork planks arrive at the mill, they are kept at room temperature for a while. Then they go through a process called preparation, which involves boiling the planks in water, trimming them, and sorting them into different types. There is a diagram of how things are set up. The reproduction cork planks that are used to make stoppers and discs are boiled in water for 1 hour. Under the old method, the water would turn very dark brown and have a lot of foam. There would also be a lot of suspended and dissolved particles in the effluent wastewater. The current cork boiling technique and equipment have undergone significant evolution. Now the planks are stacked on stainless steel pallets and the water is treated in an autoclave made of stainless steel. Heat exchangers move the water around the autoclave while it is heated to 95 degrees Celsius. Filters in the water line get rid of solids that are in the water. Cork pellets are put into the empty autoclave and water is added after the lid is put on. The water is then circulated during the hour-long process. The autoclave is then emptied, the door is opened, and the pellets are taken out. The water used is not chlorinated because chlorinated substance could get into the cork and make the wine taste bad. In other situations, a stripping column is used to pull volatiles out of the hot water and concentrate them. The average chemical oxygen demand and biochemical oxygen demand concentrations and the high toxicity of the phenolic and polyphenolic compounds in the effluent waters make them a waste problem. Several processes have been suggested, such as ultrafiltration, flocculation, flotation, and fungal degradation. The main goal of boiling the planks in water is to change their mechanical properties so they can be flattened and cut more easily. This reduces the stress on growth, smoothing out the cell walls and making the cellular structure more uniform. The porosity coefficient shows that the porosity of cork decreases as the temperature of the water rises. So, boiling cork in water makes the planks better by making them bigger and reducing the diameters of lenticular channels. When cork boils at temperatures below 100 degrees Celsius, it changes size in a way that can be changed back. Boiling cork only gets a small amount of the water-soluble compounds out, which is less than 2% of cork's water extractives. This is because the extraction time and the cork water surface area are too small. So, despite what many people say, boiling cork is not done to get chemical compounds out of it, at least not under the conditions used in the industry. The purpose of changing the water often and removing the volatiles is not to get the most out of the material, but to keep the planks from getting dirty from the boiling water. After the water has been boiled, the cork planks rest and dry out in the air for 2 or 3 days. This is called stabilization. Putting pallets on top of each other helps the planks get flat. In recent years, this has changed, and shorter stabilization times are now used to prevent microbial growth that could hurt the safety of the cork stoppers for wine. After boiling, the plank's moisture level drops from 70 to 40% right away. After 2 days, the moisture content should drop to between 40 and 80%, which is considered to be a good range for working. After drying, each boiling cork plank is looked at by a skilled worker who is in charge of trimming and cutting it into a more uniform pieces for further processing. The planks are cut by hand with a knife by the trimmer or classifier. The goal is to sort through the usable planks and separate the raw planks from the pieces that can be used to make solid cork. Trimming the planks makes the edges straight and the cross sections look better. It also sorts the planks by size and quality class. To keep from losing raw materials, manufacturers of stoppers and discs do as little trimming as possible. When the cork plank is the last thing that comes out of the mill, more care is taken to make sure that the edges and thickness are the same and the quality categories are much clearer. The wet cork pieces are taken out of the planks and dried until they have 14 or less percent of moisture, which is the standard for cork. This can be done by letting the wood dry in the air for 1 to 2 years or by forcing hot air through kiln chambers. After the planks have dried, they are put on the processing line where they go through the standard operation circuit for making stoppers or discs. When the cork is dried enough to have a moisture content between 5 and 8%, which means equilibrium, between boiling the cork planks and turning them into stoppers or discs, the benefits of having more moisture on the material strength and the ability to be machined are lost. This is usually what happens if the boiling planks are not processed at a preparation mill or if they are stored for more than 2 or 3 weeks. In this case, the planks are put through a second boiling process using the same method as before, but this time for only 30 minutes.